All right, 1976 AB3. First of all, we're going to make a quick sketch of the graphs, and we get something that looks like this. And we're looking for first of all, the area of the region bounded by the two curves, and we'll do top minus bottom. We do need to find the points of intersection there, and they will be at 1 and 4, x equals 1 and x equals 4. And so the area is the integral from 1 to 4, doing top minus bottom, so it's 4 over x minus the quantity x minus 3 squared dx. Now, we do have there's a couple of ways that you could go about doing this. And in this particular case, you don't need a u substitution on that second term because the derivative is going to turn out to be dx, or the differential will turn out to be dx. So it's not really going to be a problem for us to do this without using u substitution. But if this were a little bit more complicated and you would need to do u substitution, then this is what you would have to do. And that is, we'd split it up into two different integrals, and then let's work on the second one for a moment. So u equals x minus 3, du is dx, u of 4 is 1, u of 1 is negative 2, and so we can take the next step here. And so we have 4 times the integral from 1 to 4 of 1 over x dx minus the integral from negative 2 to 1 of u squared du. And we'll go ahead and integrate those two now. The antiderivative of 1 over x is ln absolute value of x. We get 4 times the difference of ln x evaluated at 4 minus evaluated at 1. I'm going to subtract from that the integral u to the second, which is u to the third over 3. And we can bring out the 1/3. So what we need to do now is evaluate natural log of absolute value of x. Since both of the limits of integration are positive, the absolute value doesn't matter anymore. And so we have ln of 4 minus ln of 1. And since ln of 1 is 0, we end up with 4 ln of 4 over there. For the next term, we have 1 to the third minus negative 2 to the third. And negative 2 to the third is negative 8, so it's 1 minus negative 8. And so that'll be 9 over 3 is 3, so we end up with 4 ln 4 minus 3 as our final answer to part A. Okay, I'll scroll down for part B. Okay. Alright then, for the next one, we're looking to revolve this around the x-axis. And that is going to give us a washer system, something like what you see there. And it's going to be pi capital R squared minus pi little r squared. So the volume then is going to be pi times the integral from 1 to 4 of 4 over x, quantity squared, minus x minus 3 squared, quantity squared. And once again, I'm going to split up these two integrals, and that leaves me with, I'm going to bring out the, sorry, that shouldn't be 4. I have 4 squared, which is 16 pi. I'll bring out the 16 pi. And now 1 over x squared is the same as x to the negative second. And I'm going to subtract from that the integral from 1 to 4 of x minus 3 to the fourth dx. I'm going to have the same values for u, for du, for u of 4, and u of 1 as I had in the problem above. So I rewrite, sorry, and I also have a pi in front of that last expression since I distributed the pi. So I have 16 pi integral from 1 to 4 of x to the negative second dx minus pi times the integral from negative 2 to 1 of u to the fourth du minus pi over 5 u to the fifth from negative 2 to 1. And so that gives me 16 pi times negative 1/4 minus negative 1 minus pi over 5 times 1 minus negative 32. And that gives 12 pi minus 33 pi over 5 and a final answer of 27 pi over 5.